Hi, my name is Tete Jacob Richie. Welcome to my YouTube channel. Today our discussion on calculus of several variables will be on the curl of a vector field. Before the video will end today, we will learn how to find the curl of a vector field. And I will introduce you to what a differential operator also means. With our idea on a differential operator and our idea on cross product between vectors, then the curl of a vector field will not be a problem. Please, I will indulge you to check out my videos on how to find the cross product of two vector value functions, as well as the gradient of a scalar field. So, this will be a very interesting engagement, so please be my guest. So, if we have a differential operator which is equal to del over del xi plus del over del yj plus del over del zk, and a vector field which is equal to m dependent on x, y, and z in the I direction plus n dependent on x, y, and z in the j direction, then plus p dependent on x, y, and z in the k direction. And we are asked to find the curl of f. Curl of f. The curl of f is just the cross product between the differential operator and the vector field. So we say the curl of f will be equal to the differential operator cross f. And remember, when we're doing cross product of vectors, we say the cross product of two vectors. Remember, this is a vector differential operator and this is a vector field. So the cross product of two vectors is just the determinant of a 3x3 matrix, or the matrix format of it, the determinant of the matrix format of it. So we can say the curl of f will just be equal to the determinant of, remember, the I, j, and the k will form the first column. So in this place, the coefficient there, that's del over del x, then here del over del y, here del over del z. Then here the I there is n, the j here is n, and the k there is p. So having found the determinant of this matrix, it becomes the curl of the vector field, or the cross product between the differential operator and the vector field. So we look at our first example. They say if f is a function dependent on three variables, x, y, and z, and is equal to x, y squared, z exponent 4 in the I direction, plus bracket 2x squared y plus z bracket close in the j direction, plus y cube z squared in the k direction, we should find the cross product between the differential operator and the vector field f. So how do we do that? Remember, we said the differential operator is equal to del over del xi plus del over del yj plus del over del z in the k direction. So the cross product between the differential operator and f will just be equal to a matrix, a 3x3 matrix, where I, j, and k form the first column. So in I, what we have? We have x, y squared, z exponent 4. Okay, for the first, the differential operator must come first. So del over del x for the I is having I here. Then this I for the f, which is x, y squared, z exponent 4. Then j, the differential operator del over del y. Then the j direction, which is 2x squared y plus z. Then k del over del z. Then the differential operator, the k direction, which is y cubed z squared. This matrix. So I will find the determinant of this. That becomes a cross product between the differential operator and f. So what will be the cross product? Remember, the determinant of this matrix I times the determinant of what is not under the I. So that's del over del y, 2x squared y plus z, then del over del z y cube z square, then minus j. The determinant of what is not under the j. So del over del x y square z exponent 4, then del over del z y cube z square, then plus k. The determinant of what is not under the k. And what is not under the k is del over del x y square z exponent 4, then del over del y 2x square y plus z. So we find the determinant of this matrix, then that becomes the curl or the cross product between the differential operator and f, the vector field. So you know the determinant will be this times this minus this times that. So we say del over del y, then y cube z square minus del over del z 2x square y plus z. That's for the I. Then minus j del over del x y cube z square, then minus del over del z x y square z exponent 4. Then the k plus k del over del x times 2x square y plus z, then minus del over del y x y square z exponent 4. That's finding the determinant. This times this minus this times that. So, how do we solve this? So remember, this is partial differentiation of this function with respect to y. So the z will be held constant if you understand very well. So we just differentiate the y, we'll get 3y squared. Then we'll repeat our z squared. Now this is the partial differentiation of this function with respect to z. So the whole of this, you see that there is no z there. So all of that is constant. That becomes 0. Please do well to check out my videos on how to do partial differentiation on YouTube. Then, so all of this is 0. So we have 0 plus the differential of z is 1. That's the differential of z, that's the differential of this function with respect to z will be 1. 0 plus 1 is 1, so we can say minus 1. So minus 1. That's for the I direction. Then minus j, what do we have? We'll do a partial differentiation of this function with respect to x. Since there is no x there, the whole of that is 0. So we can say 0 minus. Now, the partial differentiation of this function with respect to z, x and y will be held constant. So when we differentiate that, we get 4x y squared z cubed. Then plus k. The partial differentiation of this function with respect to x. When we differentiate this, we'll get 2x then y. That's y will be held constant. Plus the differential of that. Since there is no x, that is constant, it becomes 0. Then minus the partial differentiation of this function with respect to y. X and z will be held constant. So we have 2xy z exponent 4. I hope you get this. So when we check the partial differentiation of this, we are differentiating x. So if we drop this, it's 4, not 2. There is 2 there already, so this becomes 4xy minus 2xy z exponent 4. So when we polish this very well, you can say the curl, that's del cross f will be equal to 3y squared z squared minus 1, and all that in the I direction. Then look at the 0 minus this, that will be negative 4x y squared z cubed times negative j, that will be positive. So we say plus 4x y square z cube in the j direction. Then plus our 4xy minus 2xyz exponent 4 in the k direction. Then this becomes the cross product between the vector differential operator and the vector field. So we solve our second example on this. They say if a vector field f, which is dependent on three variables x, y, and z, is equal to x squared y shin z in the I direction plus cos inverse of x y squared z in the j direction plus x squared dash inverse of y z cube in the k direction. We should find the curl f or curl of f. Remember, the curl of f is a cross product between the differential operator and f. And what's the differential operator? The differential operator is giving us del over del x in the I direction plus del over del y in the j direction plus del over del z in the k direction. So, when we are asked to find the cross product, that's the curl of f is just the cross product between the differential operator and f. And what is that equal to? Since both the scalar field, the vector field and the differential operator are three-dimensional vector space, their cross product will be the determinant of a 3x3 vector, where the I, j, and k form the first column. So we have I, the differential operator, del over del x, then we have for the I here, for the f will be x squared y shin c. Then we go to the j, del over del y, then for that will be cos inverse of x y squared z. Then k del over del z. Then the component for the k there is x squared dash inverse of y z cube, the determinant of this matrix. And how do we find the determinant of a 3x3 matrix? Is I, the determinant of what is not under the I. So what is not under the I is del over del y cos inverse of x y squared z, then del over del z, del over del z, what x squared dash inverse of y z cube, then minus j, the determinant of what is not under the j, and that will be del over del x squared y shin z, then del over del z x squared dash inverse of y z cube, then plus k, the determinant of what is not under the k, and what is not under the k is del over del x squared y shin z, then del over del y cos inverse of x y squared z, so cos inverse of x y squared z. So how do we find the determinant? So this times this minus this times that, then this times this minus this times that, then this times this minus this times that. So we'll have this times this minus this times that. So that will be del times del y times del over del y times x squared dash inverse of y z cube, then times that. Then this times this minus this times this times this minus this times that. So that's what I've displayed there. Check it well. So now we have I. So what are we going to do here? We are going to perform a partial differentiation of this function with respect to y. So x and z will be held constant. So first we just keep our s squared. How do we differentiate touch inverse of y? So this is a differentiation of inverse hyperbolic function. Please check out my videos on how to find the derivative of inverse hyperbolic functions on YouTube. So this will just be 1 over 1 minus y squared. If you check it, then we repeat our z cube minus. So we are going to perform partial differentiation of this function with respect to z. So when we differentiate all this, the whole of this is constant. We differentiate that, it will just be the constant. We have cos inverse of x y squared. Please, the cos inverse is only affecting the x. So that for the I direction, then minus j. We perform another partial differentiation of this function with respect to x. So tan inverse of y and z cube will be held constant. So we just differentiate x squared, get 2x. Tan inverse of y z cube. Here too, the tan inverse is only affecting the y. Then minus. We perform a partial differentiation of this function with respect to z. So what happens? The x squared and the y will be held constant. So we have x squared y. The differential of shin z is cos z. That's for the j direction. Then plus k. We perform a partial differentiation of this function with respect to x. So the differentiation of cos inverse of x. Please, this is the differentiation of inverse cyclic functions. Check out my videos on how to differentiate inverse cyclic functions on YouTube. So on differentiate this, we'll get negative 1 all over the square root of 1 minus x squared. Then times our y squared z, then minus. We perform the partial differentiation of this function with respect to y. So x squared and shin z will be held constant. So when we differentiate that, it will just be the constant. X squared shin z. So try to polish this out. So we say this is equal to, we'll multiply, so we get x squared z cube over 1 minus y squared, then minus cos inverse of x y squared, and all that in the I direction. We want this to be plus, so this will affect this negative, it will affect that positive. So we'll bring this first. So plus x squared y cos z minus 2x tan inverse of y z cube, and all that in the j direction. Then plus negative y squared z over the square root of 1 minus x squared minus x squared shin z, all that in the k direction. I hope you understand this very well. Very simple. So we'll solve our last question on this, but before we do that, please remember to subscribe to my YouTube channel before you sign out. It is the only way you can help me promote my YouTube channel so that I can record more mathematical content for you. Is it given that a vector field f, which is dependent on 3 variables, x, y, and z, is equal to 5 exponent x, y, shin z in the I direction, plus cos inverse of x, y squared cosec z in the j direction, plus s squared tan inverse of y z cube in the k direction. We should find the cross product between the vector differential operator and the vector field. So how do we do that? Please, you can pause the video and try solving. After that, you compare your answers with mine. So now you can compare your answers with mine. So remember, the vector differential operator is giving us del over del xi plus del over del z j, del over del yj plus del over del zk. So, if we ask to find the cross product between the vector differential operator and the f, which is also a vector form, it will just be the determinant of a 3 by 3 matrix. So we said that a del cross f will be equal to a determinant. That's I, j, and k forming the first column. So we have the differential operator del over del x. That's is having I as its coefficient. Then the vector differential, the vector fold, which is 5 exponent x, y, shin z. Then in the j direction, del over del y, and what is under the j in the vector fold? That's cos inverse of x. Please, the cos inverse is only affecting the x. Then y squared cosec z. Then in the k direction, you have, or under the k, you have del over del z. Then in the vector fold, we have x squared tan inverse of y z3. So what will be the determinant of this matrix? To be I, the determinant of what is now under the I. That's del over del y, cos inverse of what? Of x, y squared, cosec z. Then del over del z, what is another? We have x squared tan inverse of y z3. Then minus j, the determinant of what is not under the j. And what is not under the j is del over del x, 5 exponent x, y, shin z. Then del over del z, x squared tan inverse of y z. Here the tan inverse is only affecting the y as well. Then plus k, the determinant of what is not under the k, and that's del over del x, 5 exponent x, y, shin z. Then del over del y, cos inverse of x, then y squared cosec z. So what do we do? This will multiply this minus this multiplying this. Then this multiply this minus this multiplying this. This multiply that minus this multiplying this. So having multiplied their respective distances, we'll have this. Then now we perform the partial differentiations. So in the I direction, we are going to have the partial differentiation of this function with respect to y. So x and the z will be held constant. So I have our x squared. When I differentiate tan inverse of y, I'll get 1 over 1 plus y squared. This is a differentiation of inverse cyclic function. Then I'll repeat my z cube minus the differentiation of this. That means we are going to hold the x and the y constant and differentiate cosec z. So we have cos inverse of x, y squared. When we differentiate cosec z, we get negative cos z cosec z. Please check out my videos on that. That's the differentiation of hyperbolic functions. Then minus j, the differential of this. So we are going to have the y and the z constant. On differentiate this, we just get 2x tan inverse of y z cubed. Then minus This one we are going to have the x and the y constant and differentiate with respect to z. So we have 5 exponent xy. When differentiate shin z, you get cosec z. Then plus k. Now here we are going to differentiate with respect to x. So the y and the z will be held constant. When differentiate cos inverse of x, we get negative 1 all over the square root of 1 minus x squared. Then we repeat the y and the z. So y squared cosec z. Then minus, here we are going to differentiate with respect to y. So we just have 5 exponent x shin z. Please, 5 minus 5 exponent x shin z. I hope you get that. So when we polish this very well, we can say that del cross f is equal to, we have x squared z cubed all over 1 plus y squared. And because of this are negative, it will be plus, so plus cos inverse of x y squared cos z cosec z, and all this in the I direction. Because of the negative times this will be positive, then times this will be negative. So we'll bring this first. So plus 5 exponent xy cosec, this is cosec, right? 5 exponent xy cosec z. So it's cosh. That's the differential of shin is cosh. So we have y cosh z, then minus 2x tan inverse of y z cubed. And all this in the j direction. Then plus negative y squared cosec z all over the square root of 1 minus x squared, then minus 5 exponent s shin z, and all this in the k direction. I hope you get that. So this becomes the curl of the vector field. So we'll end it here today. Remember to subscribe to my YouTube channel. As I said, it is the only way you can help me promote my YouTube channel. Until we meet again, please share my videos and like. My name is Determinants.